Hello class, I am Professor Scher, and I will be demonstrating some properties of air today, or gas laws more specifically. But before we begin, I'd like to make sure you have all of your necessary materials. That will include 2 plastic cups, one with a hole in the bottom and one without, 2 pieces of newspaper you can crumple up and tape into the bottom of the cup, so you will need tape as well, and then one 1,000 milliliter beaker and fill that with 600 milliliters of water. Make sure you have your newspaper properly taped into your 2 cups, and then you're ready to begin the experiment. Now once we have placed our paper towel in the cup without the hole in it, we're going to simply put it in our beaker that contains 600 milliliters of water and place it in there as shown. Now once you do that, you will see what happens. Now we will cut to the video showing me performing the experiment. Okay, so now we have our results back, and as you can see in the videos, or may not have been able to see, the first one without a hole in it, it did not get wet, and that is because the gas remained in there and had no way to escape. So we put it in the water, and then the gas stayed in the cup because it had nowhere to go. Unlike the second trial, when we had a hole on top of the cup, the gas came out the top of the cup and I could feel it on my hand, and the water started coming up and causing the newspaper to get wet. Hello students, it's me, Professor Scher again, and now I'm in the real world. I have left the laboratory, and I would like to explain about a real-world example of how air or gas molecules take up space. Now imagine we're at a campfire, or we have a candle. Now, if you put your hand over the campfire or candle, you can feel the warm air molecules rising up to touch your hand. And that's amazing, but where does the cold air molecules that used to be there go? The answer is they sink down because they are more dense than the hot air molecules. The hot air molecules rise because they are less dense than the cold air molecules, which sink. This is because of a thing called convection currents, which explains how warm air rises because it is less dense, and cold air sinks because it is more dense. This explains that gas does in fact take up space, or else this law of convection currents would not apply. Here's another real-world example for you. Imagine you're hiking through the Davis Mountains or some other area 8,000 feet above sea level, and you start to feel a little nauseous or queasy or lightheaded. Why does this happen? This happens because of a thing called altitude sickness. Altitude sickness occurs because the air is too thin for you to breathe normally. The higher above sea level you get, the thinner the air gets, making it more difficult for you to breathe. It becomes less dense, therefore harder to breathe. This once again proves that air does take up space, more space closer to sea level, and less space farther away from sea level. So next time you finish hiking Guadalupe Peak, be thankful that you don't live on the top, and that you live in an area where you can breathe and sleep comfortably. Thank you for watching this video. Be sure to listen to my other lectures about the composition of gas laws, film techniques, and pug physiology. Be sure to subscribe and check out my other videos. I'm Professor Carter Scher.